mean, what we're really trying to do is to understand how do the oceans work in the context of the planet and the environment. And that's a huge ongoing exercise, which is developing very rapidly. I mean, there are some really exciting international programs and very exciting technology that's being used.
Traditionally, ships and offshore structures have been designed using test tanks. I mean, the test tanks have been running for more than 50 years, and the techniques are well established. But the application of these test tanks to ocean energy conversion is a new area, because there are specific behaviors of these ocean energy systems which are different from ships, and they're different from oil rigs. Most of the time, you don't want the ship to be really tossing around too much in the waves. The oil rigs, certainly you don't want them to move around, because the guys don't like to be on the oil rigs when they're moving all over the place. So the oil rigs tend to be a stationary structure, whereas the wave energy device needs to respond to the waves to get the energy out. So it's a very different technique of system that we're dealing with, but the basic principles are well established over long periods of time.
This is the great challenge. I mean, what we're working on at the moment are completely novel systems which will enable us to understand over time what's happening in rivers, lakes, bays, estuaries and coastal seas, because of course they're all connected. And what we're trying to do is to develop not only the technologies that can do that, the sensors themselves, the way sensors can speak to each other, the way they can interpret the information that they're collecting, but how all of this information can be fed back through basically a sort of a data management mechanism, which will not just give you these kind of raw numbers that, you know, you're getting temperature A, B, C, D, E, you know, and this goes on, but that will interpret this information for different users. So whether you're somebody who wants to go to the beach and see, you know, does this make sense for us to go to the beach with the kids this weekend? And, you know, can we find out, you know, what are the conditions in Coney Island or wherever it is we want to go? Or from the point of view of a water quality manager, you know, a state or a federal authority that needs to know, are pollutant levels being exceeded? Is there a danger to drinking supplies? Are there buildups of nasty organisms in the water that's feeding into public drinking supplies? So every kind of user of information about the marine environment requires different kind of information for different purposes. And what we're working on are ways of doing all of this in real time, so that we can take all of this information, link it together and present it to a whole variety of users from the perspective that they want it.
I was a civil engineer originally. I graduated as a civil engineer, and I worked on building docks for a number of years. And then I went back and did a degree in oceanography. So I have a degree in oceanography as well as a degree in civil engineering. And I did my PhD then on the action of waves on beaches. And originally I'm from Wales, not from Ireland. But when I moved to Ireland in 1975, I could not believe the scale of the energy available in the waves, because waves are my thing. That's what I was working on the beach problems. And in beaches you get erosion because of the wave energy. And then when I looked at the options, the possibility of harnessing this energy, if you look at the whole of the west coast of Ireland, there is something like 10 times as much energy every second being dissipated as the whole of the electricity of the island. So if you could harness all of that, it'd be fantastic. But I mean, you don't need to do that. Yeah. But that really fired me into it then. You know, so we still continue to do the work on the beaches and the breakwaters. But for the last 20 years, I've been working really to try and make this industry happen.
I mean, if we crack the technology challenge in harvesting wave energy in the Irish case, which is the big resource for Ireland, you know, because we've got this big Atlantic sort of that you know, the weather systems start over here and they end up with us. They cross 3,000 miles of ocean. You've got big waves pounding up against the whole Irish coast, a huge energy resource. And if we can capture that, if we can find the technology to capture that, we can probably supply about 60–70% of our total electricity requirements in Ireland. And, you know, the way this will happen will be that you will have arrays of very large devices, maybe 5,000 tons, hundreds of these kind of moored in chains off the coast, 50, 100 miles off the coast, feeding into large-scale sort of cables that that bring that electricity ashore and distribute it throughout the grid in Ireland. And this is the scenario we're working towards.
We can't afford to choose from a menu of only the big options. We need an approach that provides us with a diverse energy portfolio of clean energy sources. And I think tidal is going to be one of them, wave energy is going to be one of them, wind energy is going to be one of them, offshore wind is going to be one of them. We're going to need to do it all.
So if you then put a 1 meter machine in Ireland or on the west coast of Oregon, you can power 600 light bulbs.
There are sort of three classes of problems around ocean energy. First is devices themselves and how you actually, get a machine that can convert the motion of the waves or the energy in the waves through some kind of device that produces this in terms of electricity. Then there's the question of how do you handle the electricity, because devices will tend to move intermittently and so on, so you've got to find a way of bringing this electricity together, smooth it, condition it so that it's capable of going into the grid, not in a kind of a jerky, jumpy way that blows fuses all over the system, but that is actually sort of usable by people. And thirdly, you've got to find a way of operating and managing large pieces of complex technology in a very hostile dynamic environment. So there are three whole sets of problems in doing this. And I suppose most of the work to date has been in the first area around the devices themselves, which is understandable. But there are very big challenges in managing the electricity that these produce. And of course, given the fact that this is a really hostile, difficult environment, there are very big challenges around security, actual survivability, making devices stay out there and not get smashed up, break their moorings, drift around, components breaking and so on, and even developing sort of the materials in the devices so that the kind of the salt and all the other nasties in the marine environment don't degrade these devices very quickly.
Fossil fuels are on the decline in terms of their supply, and they're not renewable. We can't manufacture new fossil fuels. So renewable energy is different because generally it doesn't end. If it's windy here today, it will be windy here 100 years from now. And that's why if you put up a wind turbine on a spot, you can kind of depend on there being free fuel for that spot for eternity, as long as we don't change the climate.
So it's not going to be easy, but the rewards are potentially huge because, at the end of the day, the energy is free.
We build models of these in our test tanks, and we model the ocean. We make the waves at scale, we make the tides at scale, and we look at the effects of those on the models of the proposed structures.
We have about a dozen devices around the world that are sort of serious candidates for going to full-scale or arrays of full-scale devices, with a whole clutch of new ideas coming along behind that. So it's a ferment it's an inventor's kind of paradise at the moment. There's a ferment of ideas going on, and you can see the growth of activity around the world. There's a lot of new people beginning to come into this area, including utilities and oil companies and finance companies, who are seeing that it has got to a certain plateau and is now beginning to be, we're beginning to see the bones of what's going to become an industry.